This is lesson 2.5, the distributive property. This is what the distributive property says. If A, B, and C are real numbers, then the product of A and the quantity B plus C equals A times the quantity B plus C. This becomes AB plus AC. You must distribute that A and multiply it by both numbers inside the parentheses. Another case is if you have a quantity at the beginning, like B plus C, and multiply it by A, then B must be multiplied by everything outside the parentheses, so it becomes B plus A, and C must be multiplied by everything outside the parentheses, which is A, so that becomes CA. You end up with BA plus CA. That's exactly the same as what you had in the first problem, because order of operations in multiplication doesn't matter. So it doesn't matter whether it's CA or AC, you're still getting the same answer. In the next one, the product of A and B minus C, so now we have a negative to deal with. We have A times the quantity B minus C, and that equals AB minus AC. Be very careful of the negative. Right? That negative has to stay with the C. So when you multiply A times the opposite of C, you get minus AC. In the second example, the quantity of B minus C times A, you're going to take everything that's in the parentheses in the quantity and multiply it by what's right outside. So it's going to be B times A, but then again, it's the opposite of C times A, so that's minus CA. Take a look at these next two examples. 4 times the quantity y plus 3. You must distribute that 4 to both terms that are inside the parentheses. So it's going to be 4 times y and 4 times positive 3. So it becomes 4y plus 12. Right underneath that, you have n times n minus 9. N times n is n squared. When you multiply variables, you add their exponents. That's how we get n squared. Be very careful, that is not 2n. It's n squared. And then n times minus 9 is minus 9n. It's a convention that the number always comes before the variable, so it shouldn't look like minus n9, right? Make sure you put it in the order as I've written it there. If we jump over here to the top, y plus 7 times y, you have to distribute the y that's inside out. Okay? So it's going to be y times y. Again, when you multiply variables, you add their exponents. That becomes y squared. And then 7 times y is 7y. So you have y squared plus 7y. In the second one, we have 2 minus n times 8. 2 times 8 is 16. And minus n times 8 is minus 8n. Again, we've switched the order of those terms around because it's convention that the number always comes before the variable. These are some examples of distributing the negative. So a negative number is being multiplied by some quantity in parentheses. It's key that you multiply the negative through. Okay? The negative stays with the number it's with. Do not drop the negative. So in the first case, we have negative 2 times the quantity x plus 7. We multiply negative 2 times x to get negative 2x, and negative 2 times 7 to get negative 14. In the second one, 5 minus y times negative 3y. The 5 times negative 3y is negative 15y, and minus y times minus 3y is positive 3y squared. When you multiply y times y, you add the exponents. That's how we got y squared. And negative 1 times negative 3 is a positive 3. That's how we got positive there. In the last example, we actually have negative 1 times the quantity. Now, when you see a negative in front of parentheses, we're assuming there's a 1 there. So it's negative 1 times the quantity, 2x minus 11. That becomes negative 2x, and minus 1 times negative 11 is positive 11. We're going to take a look at terms and coefficients here. This is vocab, and we're going to use this vocab from now on so that you understand what I'm talking about when I say terms, when I say coefficients, when I say like terms. So it has to be very clear in your mind what these things are. All the parts of an expression that are added together are called terms. And the numbers that are before the variables, the numbers that are being multiplied by the variables, are called coefficients. A constant is a number without a variable. It just sits alone. It can be negative, it can be positive, it can be a fraction, it can be a decimal. It doesn't matter. But a constant is not being multiplied by any variable at all. So in the expression in the example, the opposite of x plus 2x plus 8, each part of this expression is a term. So the terms are the opposite of x, 2x, and 8. In this, you have two variables. The numbers before the variables that are being multiplied by them are called coefficients. So negative 1 and 2 are coefficients. And then lastly, at the end, we have a number sitting all by itself. That's a constant. 8 is a constant. Now, when you look at all these terms, we have to determine what are like terms. Like terms have the exact same variable parts, and those variables have to be raised to exactly the same exponent. So in other words, 2x and x are like terms because they have the same variables and the variable is each raised to a power of 1. But 2x and x squared are not like terms. Yes, they have the same variable, but those variables are raised to different exponents. They can only be combined if they are like terms. So if you look at this next one, the x plus 2x plus 4, x and 2x both have the same variable, and they're raised to the same power, so they can be combined. So you can add x and 2x together, and the way you do that is you add their coefficients. So we're adding 1x plus 2x, and we get 3x. The 4 is a constant, and a constant stays the same, so we just add 4 to the end. So given an expression, you should be able to identify the terms, the like terms, the coefficients, and the constants. Let's take a look at this example. We have 3x minus 4 minus 6x plus 2. In this case, the terms are everything that's listed there. So it's 3x, negative 4, negative 6x, and 2. The like terms here are the ones that have variables that are same raised to the same exponents. So we have 3x and negative 6x. And then the constants. The constants are always like terms. You can always add numbers together. So we have negative 4 and 2. The coefficients here are the numbers that are being multiplied by variables. So we have 3, because we have 3x in the example, and negative 6. That comes from the negative 6x. The constants here are the numbers in the expression that sit alone. Remember, they're not being multiplied by any variables. So we have negative 4 and positive 2. Look at the expressions below, and using the distributive property, we want to multiply terms and then combine the like terms. So we're going to use everything we've gone through in this section so far. We have 4 times the quantity n plus 9 minus 3 times the quantity 2 plus n. So the first thing we want to do is distribute. We're going to multiply these numbers out. So we're going to multiply 4 by everything in this parentheses. So it's 4 times n plus 4 times 9. That's 4n plus 36. And then we take minus 3 and we multiply it by 2, n minus 3 times positive n. So that becomes negative 6 minus 3n. Watch the distribution of negative. That negative has to stay with the 3. So it's negative 3 times 2 and negative 3 times n. Okay? The next thing we're going to do is combine our like terms. Okay, so here we have several terms that are the same. We have two n terms, n raised to the 1, that's 4n and a minus 3n. And then we have two constants. We have 36 and minus 6. When you combine terms that are variables, you only combine their coefficients. So when you take 4n minus 3n, you get n. You're subtracting the coefficients. Okay? Think of it as things. Think of it as 4 apples minus 3 apples, and you'll understand that you have 1 apple. Don't change the exponent on the n. This is key. The n has to stay the same. And then you have 36 minus 6, and that becomes 30. Okay? So try the next one. We have 2 times the quantity, x minus 8, minus 4 times the quantity, x plus 3. You have to distribute those numbers. So we're going to multiply 2 times the quantity, and then we're going to multiply minus 4 times the quantity. So you get 2x minus 16. Again, watch the negative here. We have a minus 4 times x, that's minus 4x. And we have minus 4 times positive 3, that's minus 12. Then you combine your like terms. We have 2x terms and we have 2 constants. So we're going to combine the coefficients on the x terms. We have a 2x and a minus 4x. That becomes a minus 2x. And we have a negative 16 minus 12. That's minus 28. Take a look at this word problem. Your daily workout plan involves a total of 50 minutes running and swimming. You burn 15 calories per minute when you're running and 9 calories per minute when you're swimming. Let R be the number of minutes that you run. Find the number of calories you burn in your 50-minute workout if you run for 20 minutes. Now, if your workout's 50 minutes and your running time is R, they told you that at the beginning, then your swimming time must be your total amount you're working out, 50, minus R, the time you're running. That's the swimming time. You can think about the problem this way. Your total calories burned during your workout are your calories burned from swimming plus your calories burned from running. And remember that your number of calories burned is your calories burned per minute times the number of minutes that you do the activity. So if C is our total calories burned, that's going to be 15 times R, 15 calories per minute of running, right, times R, which is the number of minutes you run, plus 9, the number of calories you burn per minute swimming, times the time that you swim. We stated at the beginning that the time that you swim is 50 minus R. You must distribute that 9 to work this problem out. So this is going to be calories equals 15R plus 450 minus 9R. You must combine your like terms. We have a 15R and a minus 9R. That becomes a 6R. So it's 6R plus 450. Now we're close. But in the problem, it says find the number of calories you burn if you run for 20 minutes. So in other words, if R is 20. So we're going to substitute 20 for the value of R. So the number of calories burned is 6 times 20 plus 450. That's 120 plus 450. That's 570 calories. Okay? Make sure you understand the setup of the problem. It's really key to define your variables at first and think it through. If you need to write it in words first, then write it in words and then start assigning variables and make sure it makes sense.